Hey guys, welcome back to the Wood Metal Workshop. I'm Kent, starting out on a new project today. When we built the shop, we designed for a jib crane. Underneath this section of floor, there is a full cubic yard of concrete sitting under the 6-inch slab. So, with a full rebar cage and these 8 5/8-inch J-bolts coming up through the floor, along with conduit for power. So this is where the jib crane was designed to go. Never got around to sourcing or building a jib crane until now. So now we're building a jib crane. I want to tell everybody, do not build a jib crane unless you're an engineer and you can spec everything out to handle the weight that you're expecting. Now this is a light duty jib crane that we're building. Figure the maximum thing that I'm ever going to lift, probably around 300 pounds. It's to lift stuff onto the lathe and the mill. It's not for pulling engines or doing that kind of stuff, even though I have sized the I-beam to reach pretty much to the center of the driving lane in the shop where we put vehicles. That is to lift materials out of the truck onto the lathe or the mill. It's not for moving machinery. It's not for pulling engines, that kind of stuff. 300 pounds. That's it. Okay? I've actually spec'd it to be safe probably at 1,000 pounds, but never going to lift anything that heavy. And in fact, I'm going to spray on the beam 300 pounds. Just so everybody knows, 300 pounds. Do not build one of these yourself. Anyhow, so we got anchor bolts in, so we're going to make base plate, circular base plate for this. Do a cutout so the power comes through. This is the power that goes to the American rotary phase converter. Off of that, there's going to be a second plate here that will, jib crane itself will get welded to with gussets. So kind of working around this. This wasn't the original plan, but this is what we've got now, so now we have to work with it. Alright guys, let's get on with the build.
Alright guys, here we go. We're loading up our chunk of 1018, 18 inches long, 3.5 inches in diameter. This is going to be our pivot pin. Mr. Booth and Mr. Fenner have no worries about me or Coben taking away the 4-jaw championship from them anytime soon. But everybody's got to learn sometime, right? So I'm just going to push the live center up against the butt end here to hold it in place. Then I bumped it around and drilled it, and then put the live center back in, marked it there for our 13 inches, which is a nominal dimension, but of course we're going to try to hit it exactly. Got my feed rate set. About here's where I'm realizing that there's something wrong. I'm just not exactly sure what is wrong. That's my inexperience on the lathe showing.
But we've been asked to do another t-shirt campaign, so we signed up with T-Blaster to get you these awesome shirts up to size 5X. You can go to tblaster.com/woodandmetalworkshop. Campaign starts on August 30th, ends September 20th at midnight 2017. All the proceeds from t-shirt sales go right back into making more great videos for you guys, and we really would appreciate it. And I think that's it.
So
back
just
to the
checking
video.
things, going, yeah, something's not right. So put the indicator back on there and recentered that end, and that seems to have taken care of our issue. Proof's in the pudding, though, and here we go. We're making another very light cut just to see what's going on here. Putting oil in all the oil cups while it's running, and it's nice and even now. One more cut here, one more test. Now one more cut, and you can see the sparks coming off there. It's doesn't show up when you're there in person, but video picks it up really nicely. That insert is not cutting the way I hoped it would. That's a new one I was trying out. So, switch inserts. There we go. 50 thousandths total, 25 aside. Don't remember what the feed rate was. There's my improvised chip deflector. And there's the pile of nice blue chips there, coming off gold and brownish gold and turning blue almost right away. So, my understanding is that's what you want.
Cooled off enough to the touch. Let's get ourselves a quick check. See where we're at. 2 inches, 70 thousandths. 1 inch, 616 thousandths. So this needs, the measurement we're going for that one is 1 inch, 495 thousandths. And the measurement we're going for this one is 2 inches dead on.
Alright, we're going to make our final cuts to size here. It's not 1495, it's 1474, something like that, for 75% threads on a 1.5" 6. But the other dimension was right, 2 inches. Lathe is actually turning out to be a pretty darn good, pretty accurate lathe. Yeah, take your time and pay attention to what you're doing. You hit your numbers pretty darn close, as proof will be here in just a second. I cut the 2 inch. There's the final pass on the 2 inch. 1997. Couldn't ask for a better cut than that. Alright, single pointing. This is practice. I practiced quite a bit before this, but evidently not enough. I was having some problems with engagement, and then my crossfeed dial was slipping a little bit, so I was having some issues. A lot of it was the pressure of working on a $100 piece of steel, not a scrap piece of steel. But gotta get her done. And here's where I chickened out and switched to the die stock. That's a 24-inch proto wrench I picked up last summer. You can see that in an auction action video. There's the nut going on. Fits perfectly. Okay, UHMW. This was fun to turn. I was really enjoying this. Really need to get some bigger, long drill bits. This one was just big enough to fit the bit on the boring bar without shortening up the bit anymore. Got bigger drill bits, just none long enough to reach all the way through. And the boring bar isn't long enough to reach all the way through either. I'm leaving about 3/4 an inch at the far end there. I'll have to come back and clean that up from the other side. But it's cutting. Nice high-speed steel tool that I ground there. UHMW does make a mess, though. Test fit, didn't fit. Make another pass. Test fit again. Still doesn't fit. This is the final pass here, and I was getting a really nice finish on that. There it fits. Okay, now we'll switch over to the 3-jaw chuck. And grip it from the inside. We'll finish boring the center. I was actually quite surprised how well the bores lined up. Only a few thousandths difference. Which in some parts might make a difference, in this part it really doesn't. Alright, turning the outside. High-speed steel again. Leaving a 3/4 inch ring there at the top. Cut it down to 3.5 inches so it will fit inside our pivot tube. Once again, beautiful finish on that. Alright, we're going to go ahead and cut some gussets here. I'm using the Milwaukee metal cutting saw to do this. Making some really nice cuts. lining them up. You know, so a couple were a little short. Okay, now we're making the washers. Had to get the washers made so we could get the bushings to the proper length. Sorry, I missed the video, lost the video for boring and drilling and boring the centers. Did that on the 4-jaw, and then switched over to the 3-jaw once again to grab them from the center so I could turn the outside down to size. Alright, there's the stack up. Ended up measuring it out. Need to take 1/4 inch off each one. Did that. Back together, and it fits. Alright, now we're drilling out the base plate. On a 3/4 inch hole for the 5/8 inch bolt. Give us a little bit of wiggle room. In this application, the bolt does not have to fit tight. Having a DRO would be nice here, but don't have one. So it's mark it out by hand and just line it up and drill it. Alright guys, catch you in the next video. Thanks for watching.